Hello everyone, welcome to this test review video for Math 1225. In this review, we will go over problems covering the main topics that will appear on test 2, including derivative rules, chain rule, implicit differentiation, logarithmic differentiation, related rates. I strongly recommend that before watching the solution, you pause the video and try each problem on your own first. Then, compare your work with the solution and identify any mistakes. Let's start with problem 1. We are given a table containing values of f of x, f prime of x, g of x, and g prime of x. And we want to evaluate ddx of g of 5 plus f of x at x equal to negative 5. Whenever we have a function inside another function, that should immediately remind us of the chain rule. So, therefore, you can consider y as g of 5 plus f of x. Applying the chain rule gives y prime is equal to derivative of outside function. Outside function in this case is g. Derivative of outside function would be g prime of like inside function back in. So this is inside function. So g prime of 5 plus f of x times derivative of inside function ddx of 5 plus f of x. So therefore you will get g prime of 5 plus f of x times derivative of 5 plus f of x would be derivative of 5 plus derivative of f of x. So therefore we will get g prime of 5 plus f of x times derivative of 5 is 0, derivative of constant numbers is 0, and derivative of f of x would be f prime of x times f prime of x. Now let's substitute x equal to negative 5. So if you like x equal to negative 5 for x, y prime would be g prime of 5 plus f of negative 5 times f prime at negative 5. So, therefore, you need to find f at negative 5, f prime at negative 5 using the table. So, using the table, f at negative 5 is negative 3. So, g prime of 5, f at negative 5 is negative 3, times f prime at negative 5. f prime at negative 5 is 5, times 5, which is equal to g prime of 5 minus 3 would be 2, times 5. So, now you need to find g prime at 2. g prime at 2 using the table would be g prime at 2 would be negative 5. Negative 9. Negative 9 times 5 would be negative 45. So the final answer is negative 45. Notice that the most common mistake on a problem like this is forgetting to evaluate g prime at 5 plus f of x. It means g prime at 5 plus f at negative 5, which is 2, not negative 5. So let's move on to problem 2. In this question, we want to calculate the 13/35 derivative of f of x equal to sine of x minus e to negative x. As you learn for a high order derivative, the key idea is to look for a pattern. First, let's look at the sine part. So, for sine of x, we are going to find 13/35 derivative. Let's find the first derivative of sine. First derivative of sine would be cosine. Derivative of cosine would be negative sine. Therefore, second derivative would be negative sine. Derivative of negative sine would be negative cosine of x. Therefore, the third derivative would be negative cosine of x. Derivative of negative cosine of x would be sine of x. Therefore, the fourth derivative would be sine of x. So, after 4 steps, as you can see, we back to the original function. We back to sine of x. This means derivative of sine repeat every 4 steps. This means derivative of the first derivative and, for example, 5's derivative for sine or cosine of x. Second derivative and 6th derivative for sine or negative sine of x. Third derivative and 7 derivatives of sine or negative cosine of x. Fourth derivative and 8th derivative of sine or sine of x. So, if you look at these numbers, we can realize, for example, for 1 and 5, if you divide these numbers by 4, remainder would be 1. If you divide these numbers by 4, remainder would be 2. If you divide this number by 4, remainder would be 3. And if you divide these numbers by 4, remainder would be 0. Therefore, to find 13/35 derivative of sine, you need to divide 13/35 by 4 and find the remainder. If you divide by 4, remainder would be 3. Remainder is 3, means 13/35 would be a number here, would be a number in this row here. Therefore, 1335's derivative of sine would be negative cosine of x. So therefore, we could find 1335's derivative of sine. Now, let's look at the second part. The second part is negative e to negative x. Negative e to negative x. So, if you take derivative of negative e to negative x, you must apply chain rule. Because you have a function inside another function. So, therefore, to find derivative of this function or first derivative of this function, you need to apply chain rule and constant multiple rule, because negative would be constant in this case. So, derivative of negative e to negative x by using chain rule would be, we have a negative sign. So, derivative of e to negative x by using chain rule would be derivative of outside function. Outside function is e. But you must plug inside function back in. So, it would be e to negative x times derivative of inside function. Derivative of inside function is negative x. Derivative of negative x is negative 1. So, therefore, negative 1 times negative would be positive. So, therefore, the first derivative would be e to x. e to negative x. So, now to find second derivative. To find second derivative, again, by using chain rule, derivative of e to negative x would be e to negative x times negative 1, which is negative e to negative x. Now, look at this. You back to original function. You back to negative e to negative x. This means each time we differentiate e to negative x, we multiply by negative 1. Since we already have a negative sign in the front, the signs will alternative. Now, let's look at the second part. So, second part is negative. Now, let's look at the second part. Second part is negative e to negative x. So, if you are going to find first derivative of this function, you need to apply chain rule. So, you have a negative sign in the front, so you can consider this negative sign as a constant, and then you must find derivative of e to negative x using chain rule. By using chain rule, derivative of e to negative x would be derivative of outside function, derivative of e is itself, but you must plug inside function back in. Inside function is negative x, therefore would be e to negative x times derivative of inside function. Derivative of negative x would be negative 1. So, therefore, derivative of negative e to negative x would be e to negative x. Now, you must find second derivative. So, you need to find derivative of e to negative x. Derivative of e to negative x by using chain rule would be derivative of outside function. Outside function is e. Derivative of e is itself. So, it would be e2. You must plug inside function back in. E to negative x times derivative of inside function. Derivative of negative x is negative 1. So, therefore, would be e to negative x, which is the original function, negative e to negative x. So, now, as you can see, for this part, each time we differentiate e to negative x, we multiply by negative 1. Since we already have a negative sign in the front, the signs will alternate. So, therefore, the pattern for second part would be like this. Negative e to negative x, e to negative x, negative e to negative x, e to negative x, and so on. So, this is the original function. This is first derivative. This would be second derivative. This would be third derivative, and so on. So, therefore, as you can see, for odd numbers, derivative of this function would be e to negative x. Since 1335 is odd, therefore, negative e to negative 5, 1335's derivative of negative e to negative x would be e to negative x. Therefore, the answer for our problem, f of 1335 derivative of f would be negative cosine of x plus e to negative x. Now, let's look at problem 3. In this problem, we are not given a formula for f of x. Instead, we are given the graph of f of x. So, we need to get both function values and derivative values from the graph. So, for part A, we want to evaluate derivative of f of 3x plus 4 plus 1/2 times x. So, first of all, you need to apply sum rule. By using sum rule, derivative of this function would be derivative of first function, derivative of f of 3x minus 4 plus derivative of second function, 1/2 times x. So now to find derivative of this part, this function, you must apply chain rule because you have a function inside another function. You have 3x minus 4 inside f. Therefore, you need to use chain rule. By using chain rule, derivative of this function would be derivative of outside function. Outside function is f. Derivative of f is f prime. But you must plug inside function back in, 3x minus 4 times derivative of inside function with respect to x, ddx of 3x minus 4 plus derivative of 1/2 times x. Derivative of 1/2 times x by using constant multiple rule would be 1/2 derivative of x, which is 1. Therefore, derivative of 1/2 times x would be 1/2. So now you need to find derivative of 3x minus 4 with respect to x. So you have f prime of 3x minus 4. Derivative of 3x minus 4 using difference rule would be derivative of 3x, which is 3, minus derivative of 4, which is 0. Therefore, would be 3 plus 1/2. So now in this step, you need to evaluate derivative of this function at 3. You need to evaluate this one at 3. So therefore, if you plug 3 for x, you will get f prime at 3 times 3 would be 9 minus 4 times 3 plus 1/2. F prime at 5 times 3 plus 1/2. So now you must find f prime at 5. So f prime at 5 would be a slope of tangent line at 5. So a slope of tangent line to f at 5. So a slope of this line. You need to find a slope of this line. A slope of this line, as you can see, would be rise over run. Rise is 1, run is 2. Therefore, f prime at 5 is 1/2. So f prime at 5 is 1/2. So therefore, you have 1/2 times 3 plus 1/2. 3 divided by 2 plus 1/2 would be 4 divided by 2, which is 2. Now let's work on problem 4. In this problem, we need to find dy dx for several different types of functions. Basic function rules, chain rule, implicit differentiation, and logarithmic differentiation. So for part A, to find dy dx, first of all, let's try to rewrite our function. So you have 5 root of pi plus 1 divided by x to pi can be considered as x to negative pi minus log of x with base 5 plus 2x divided by x plus 1. So now, to find dy dx or y prime, you must find derivative of each term. Derivative of first term would be derivative of a constant, because 5 root of pi is a constant. Therefore, derivative of constant function, as you learn, is 0. Therefore, derivative of this function would be 0. To find derivative of x to negative pi, you must use power rule. So, by using power rule, derivative of x to negative pi would be negative pi x to negative pi minus 1. So, to find derivative of log of x with base 5, you must use derivative of logarithm function. So, in general, you learn derivative of log of x with base b would be 1 divided by x ln of b. So therefore, in this case, derivative of log of x with base 5 would be 1 divided by x times ln of 5 plus derivative of 2x divided by x plus 1 by using quotient rule would be derivative of top, derivative of 2x is 2 times bottom minus derivative of bottom, derivative of x plus 1 is 1 times top times 2x divided by bottom square. So therefore, you could find derivative of the first function. You don't need to simplify the final answer. For part B, look at part B. We are going to find dy dx. To find dy dx, you must find derivative of first function minus derivative of second function. So, as you can see, for both functions, you have a function inside another function. Therefore, you must apply chain rule to find derivative of them. And also if we apply chain rule to find derivative of first function, we must know what is outside function, what is inside function. In this case, outside function would be secant, inside function would be sine. Therefore, using chain rule, derivative of this function would be derivative of outside function. Derivative of secant would be secant times tangent. Secant of times tangent of. So, but you must plug inside function back in. Secant of sine of x times tangent of sine of x times derivative of inside function. Inside function is sine. Derivative of sine would be cosine of x minus derivative of 2x to the 4th minus 5x to the 12 by using chain rule would be derivative of outside function. Outside function is power function. Therefore, derivative of outside function would be 12 inside function to 11. Because you must plug inside function back in. So 2 times x to the 4 minus 5x to 11 times derivative of inside function. Derivative of inside function is 2x to the 4 minus 5x. So therefore would be secant of sine of x times tangent of sine of x times cosine of x minus 12 times 2x to the 4th minus 5x to the 11 times derivative of 2 times x to the 4 minus 5x would be derivative of first function minus derivative of second function. Derivative of first function would be 2 times derivative of x to the 4 would be 4 times x cubed minus derivative of 5x would be 5. So therefore the final answer would be secant of sine of x times tangent of sine of x times cosine of x minus 12 times 2x to the 4 minus 5x to the 11 times 8x cubed minus 5. Now let's do part C. So for part C, we are going to find dy dx. Yes, yeah, dy dx. dy dx. So here we have an implicit differentiation problem because you cannot write one variable in terms of another variable. Therefore, this equation is in implicit form. Therefore, to find dy dx, you must apply implicit differentiation method. To apply implicit differentiation method, because you are going to find dy dx, you must differentiate both sides with respect to x first. So d dx of tangent of x times y minus d dx of 2 times x is equal to d dx of x times e to the y. Now you must apply rules and formulas to find derivative of each part. So to find derivative of tangent of x, y, you must apply chain rule. By using chain rule, derivative of tangent of x, y would be derivative of outside function. Outside function is tangent. Inside function is x times y. Therefore, by using chain rule, derivative of tangent of x times y would be derivative of tangent, which is secant s square of inside function, times derivative of inside function with respect to x, minus derivative of 2 times x with respect to x would be 2 is equal to find derivative of this function x times e to the y, you must use product rule. So by using product rule, derivative of this piece would be derivative of first function with respect to x times second function plus derivative of second function with respect to x times first function. So now we need to find derivative of x times y with respect to x, derivative of x with respect to x, derivative of e to the y with respect to x. So to find derivative of x times y with respect to x, you must use product rule. So therefore, we will have secant s square of x times y times, by using product rule, derivative of x times y with respect to x would be derivative of first function with respect to x times second function plus derivative of second function with respect to x times first function. Minus 2 is equal to derivative of x with respect to x is 1 times e to the y plus, to find derivative of e to the y with respect to x, because variable of differentiation, which in this case is x, is different with variable of our function, which is y, you must use chain rule. So therefore, to find this derivative, you must use chain rule. So chain rule says, take derivative of outside function, plug inside function back in, then multiply by derivative of inside function. So derivative of outside function would be e to the y. Outside function is e. Derivative of e would be itself, but you must plug inside function back in. Therefore, would be e to the y times derivative of inside function with respect to x. Inside function is y. Derivative of y with respect to x times x. So now, as you can see in this step, we need to simplify our expression. We have secant s square of x times y times derivative of x with respect to x is 1. 1 times y is y plus derivative of y with respect to x is dy dx times x minus 2 is equal to e to the y plus e to the y times dy dx times x. So now by using distributive property, you can remove this parentheses. By using distributive property, we will get secant s square of x times y plus secant s square of x times y times dy dx times x minus 2. Minus 2 is equal to e to the y plus e to the y times dy dx times x. So now you must gather all terms in dy dx one side, other terms other side. So you can keep this term on the left, secant s square of x times y dy dx times x, and you can move this term to the left as well. If you subtract e to y times dy dx times x to both sides, you will get negative e to the y dy dx times x is equal to, so we must gather other terms other side. So you can keep this term on the right, but you need to move these two terms on the right as well. Therefore, you must add two to both sides, and also you must subtract secant s square of x times y times y. So now you can factor out dy dx from all expression on the left. Secant s square of x times y times x minus e to the y times x is equal to e to the y plus 2 minus secant s square of x times y times y. So now to find dy dx, you must divide both sides by secant s square of x times y times x minus e to the y times x. Therefore, dy dx would be e to the y plus 2 minus secant s square of x times y divided by secant s square of x times y times x minus e to the y times x. Now let's do part D. For part D, we will use logarithmic differentiation method. Because you have a function raised another function, variable to variable. So as we learn, to find the derivative of this type of function, we must use logarithmic differentiation method. To use logarithmic differentiation method, you must follow 4 steps. The first step is you must take natural log of both sides. So therefore, we must take natural log of both sides. Natural log of 3t cubed plus 5t to the exponent of t. Now, by using natural log property, you must simplify this expression. So, because ln of a to the b is b ln of a, you can write down the expression on the right as secant of t times ln of 3t cubed plus 5t. On the left, we have ln of s of t. So, now in this step, you must take derivative with respect to t, because variable in this case is t. With respect to t from both sides. So, the dt of ln of s of t would be equal to the dt of secant of t times ln of 3 times 3 cubed plus 5t. Derivative of ln of s of t, by using the formula that you learned, would be s prime of t divided by s of t is equal to derivative of secant of t times ln of 3t cubed plus 5t. By using product rule, would be derivative of first function times second function plus derivative of second function with respect to t ln of 3t cubed plus 5t times first function times secant of t. So now in this step, you are okay with the expression on the left. Therefore, you must keep it. S prime of t divided by s of t is equal to, on the right, you need to find derivative of secant of t, and you need to find derivative of ln of 3t cubed plus 5t. So derivative of secant of t would be secant times tangent. So it would be secant of t times tangent of t times ln of 3t cubed plus 5t plus derivative of ln of 3t cubed plus 5t would be, to find derivative of this function, you must use chain rule. Because you have a function inside another function. In this case, outside function would be ln, inside function would be 3 times t cubed plus 5t. Therefore, by using chain rule, derivative of this function would be derivative of outside function. Derivative of ln of x would be 1 divided by x, but you must plug inside function back in. Therefore would be 1 divided by 3t cubed plus 5t times derivative of inside function, derivative of 3t cubed plus 5t times secant of t. So now we must keep the expression on the left, s prime of t divided by s of t, and also we are okay with all of this. We can copy them here. So now we just need to find derivative of this function with respect to t. Derivative of this function with respect to t would be derivative of first function plus derivative of second function. Derivative of first function by using power rule and constant multiple rule would be 3 times 3 t square plus 5 times secant of t. So therefore, derivative, we will get s prime of t divided by s of t is equal to, we are okay with all of these, we just need to simplify, times 9t square plus 5 times secant of t. So now from here, if you multiply both sides by s of t, you can find s prime of t. So therefore, s prime of t would be this one, this expression, the whole expression, times s of t, which is equal to, you at the end you must substitute the function, the given function s of t here or s of t here, and you must write down the final step in terms of t, just in terms of t. So therefore would be this one times s of t was times 3t cubed plus 5t to secant of t, and you are done. Now let's look at problem 6, which is a related rate problem. This problem says a 6 foot tall person walks away from a street light that's 18 feet high at a rate of 4 feet per second. How fast is the length of the person's shadow changing when the person is 12 feet from the base of the street light? Your final answer must include the correct units. So if you have a related rate problem, first of all, you must understand the problem. How we can understand the problem? You can draw a picture for your problem. For example, in this case, the picture can be considered as this picture that you are saying here. You have a street light, and the height for that is 18. You have a 6 foot tall person. This person walks away from a street light. Therefore, the distance between a street light and person is changing over time. Therefore, you can label this distance as x, because x is changing over time. We don't know what is exactly value for x. X is changing over time. And also, you can label s for person's shadow, and as this person walks away from a street light, s is changing over time as well. So, therefore, the picture would be like this. If you are going to, for example, consider a picture for this question, you will have a picture like this. This is 6, this is 18, this is x, this is s. So, question says, as a person walks away from a street light, its rate of change would be 4 feet per second. So, means rate of change of x would be 4 feet per second. So, therefore, we have this information from the problem. dx dt would be 4 feet per second. Question asks us to answer this part. How fast is the length of the person's shadow changing when the person is 12 feet from the base of the street light? So, question asks us to find ds dt when the person is 12 feet from the base of a street light, when x is 12. When x is 12. So, therefore, as we learn, when we have a related rate problem, we need to find relationship between noun and unknown variables. In this case, the noun variable would be x, because you have the x dt. Unknown variable would be s, because you want to find the s dt. So, therefore, you must find relationship between x and s. To find relationship between x and s, you must use the property of similar triangles. Because look at this, you have two similar triangles. This is one of them, the larger one, and this one is the smallest one. So, by using the property of similar triangles, we can find relationship between x and s. We know when we have two similar triangles, the ratio of corresponding sides are equal. Therefore, 6 divided by s is equal to 18 divided by x plus s, because the length of this triangle, this side would be x plus s. So, now by using cross product, you will get 6 times x plus s is equal to 18s. So, therefore, 6x plus 6s is equal to 18s. So, therefore, 6x would be equal to 18s minus 6s. 6x would be equal to 12s. You can cancel 6 from both sides. So, therefore, x would be 2s. So, therefore, you could find relationship between x and s. So, from here, you can find s. S would be, for example, s would be x divided by 2. Now, this is relationship between x and s. Now, you must take derivative with respect to time from both sides of this relationship. So, d dt of s would be equal to d dt of x divided by 2. d dt of s would be ds dt is equal to derivative of x divided by 2 with respect to time using chain rule would be 1/2 dx dt. So, therefore, you could find ds dt. So, now in this step, you must evaluate ds dt at x equal to 12. At x equal to 12, ds dt would be 1/2 times dx dt from the problem is 4. 4 would be 2. So, the unit for ds dt would be feet per second. So, therefore, you can say the length of the person's shadow is increasing at a rate of 2 feet per second. you can say the length of the person's shadow is increasing because rate of change is positive, is increasing at a rate of 2 feet per second. Now let's look at problem 7, which is another related rate problem. So in this problem, we know water is flowing into an inverted cone-shaped tank at a rate of 6 cubed inch per second. So therefore from here you can conclude dV dt is 6 cubed inch per second. We know the cone is 10 inch high and the base radius is 4 inch. We want to find how fast the water level is rising when the water is 5 inches deep. So let's consider, we have a picture for this question, but from this picture, we consider h as the height of the water and we consider r as radius of the surface of the water. We know the volume of the water in the cone would be 1/3 pi r square h. So, as water is flowing into the tank, h is changing over time and also r is changing over time. Question asks us to find the h dt. How fast is the water level rising when the water is 5 inch deep, when h is 5. So therefore we are going to find the h dt when h is 5. So in this question, again, we need to know what is noun variable, what is unknown variable. Noun variable would be v, volume, because we know dv dt. Unknown variable would be h, because we are going to find the h dt. So therefore we need to find relationship between v and h. The relationship between v and h would be the volume of the cone, which is v equal to 1/3 pi times r square times h. But this relationship must be between v and h, must be between noun and unknown variable. So therefore we need to find r, in terms of h. How we can find r in terms of h? So to write r in terms of h, look at the picture that you have. So if we are going to consider a picture for our problem, we will have a picture like this. This is 4, this is r, this is h, and this would be 10. So therefore, when you are going to write r in terms of h, you can use this picture. As you can see, you have two similar triangles. This one and this one. Therefore, by using the property of similar triangle, we know r divided by h would be 4 divided by 10. Therefore, 10r would be 4h. Therefore, r would be 4h divided by 10, which is 2 divided by 5 times h. Therefore, we could find r in terms of h. Now, we will back to the relationship that we are going to find between v and h. So, in this relationship, which is volume formula for the cone, instead of r, you can consider 2 divided by 5 times h. So, therefore, this relationship would be like this. 1 divided by 3 pi, r is 2 divided by 5 h square times h. So, therefore, v would be 1/3 pi 4 divided by 25 h square times h. So, therefore, v would be 4 divided by 75 pi h cubed. Therefore, you could find relationship between noun and unknown variable. Noun and unknown variable. So, now you can take derivative with respect to time from both sides of this relationship. So, if you take derivative with respect to time, d dt of v would be equal to d dt of 4 divided by 75 times pi h cubed. Derivative of v with respect to t would be dv dt is equal to, so this part is constant. Therefore, derivative of 4 divided by 75 times pi times h cubed would be 4 divided by 75 times pi derivative of h cubed with respect to t. So therefore, dv dt would be 4 divided by 75 pi derivative of h cubed with respect to t would be, by using chain rule, would be 3 h squared times dh dt. So now from here you can find a formula for dh dt. dh dt would be dv dt divided by 4 divided by 75 times pi times 3 h squared. So therefore we could find dh dt. What question asks us to evaluate this one? When h is 5. So when h is 5, we need to evaluate this one. So from the question, we know dv dt is 6. 6 divided by 5 divided by 5 divided by 75 times pi times 3 times h. You must multiply 5 for h. 5 squared would be 25. So therefore you can cancel 3 times 25, which is 75 with 75. Therefore would be 6 divided by 4 times pi, which is 3 divided by 2 pi. And the unit for this rate of change would be inch per second. So this means if you are going to interpret the final answer, you can say the water level is increasing at a rate of 3 divided by 2 pi inch per second.